Okay, let's talk about computing limits with an absolute value now. So suppose I want the limit as x goes to 1/2, and I have 2x minus 1 in absolute value over 2x minus 1. Okay, well first, because plugging in x equals 1/2 gives 0 over 0, this tells us we need to do algebra. Okay, we need to find some kind of cancellation because 0 over 0, that doesn't make sense, but it doesn't mean the limit doesn't exist. I'll do two examples, one where it does, one where it doesn't, just to show you that this is meaningless. If anything, it just means you have to do more work. Okay, so, well, we need to understand what the absolute value 2x minus 1 is. And we know from function composition, it's 2x minus 1 when 2x minus 1 is non-negative, and it's negative 2x minus 1 when 2x minus 1 is non-positive. But, I really want a more useful form of this. So I rework and I solve for x in each of these scenarios. So I have to add 1, that brings it over, and then I have to divide by 2. So I have x, is bigger or equal to 1/2, and I have x is less or equal to 1/2. And it's not a coincidence that this number, 1/2, in fact matches where x is going. Okay, so what I need to do, because this limit does not specify, there's no left or right, I have to check both. And the reason I have to check both is not just because there's no left or right, but it's also because the exact situation of being bigger or less than 1/2 is exactly what changes my function. So there's really two functions written here. It's just all implicit. If you don't know this material, it's not clear, but it turns out, yeah, that's actually what's happening. So, okay, let's check the limit as x goes to 1/2 from the right. Okay, this means x is bigger or equal to 1/2. In fact, technically just means bigger, not equal. So I look over here and aha, x is bigger than 1/2. I must be this thing, 2x minus 1. So I have 2x minus 1 over 2x minus 1. And again, if you just plug in 1/2, you get 0 over 0. That's not an answer. But, aha, eureka, 2x minus 1, that's some number. If you plug in x, you'll get some number, right? If x was 4, you would get 7. And then 7 over 7 would be 1. No matter what you plug in, it cancels. What you get is the limit as x goes to 1/2 from the right of just the number 1. And that's 1. As x goes to 1/2, the number 1 stays the number 1. It doesn't even change with x. There it is. On the flip side, if we look at the limit as x goes to 1/2 from the left of this function, so let's just do some arrows to let the reader know that we're starting with this. All right, so now absolute value 2x minus 1, well, we're in the second category now. So that's negative 2x minus 1 over 2x minus 1. And again, there's cancellation, but this time it's the limit as x goes to 1/2 from the left of just the number negative 1, which is negative 1. And now you might think if you were on a test, you're done, but you're not, because you haven't given a conclusion. What's our conclusion? Our conclusion is that the limit as x goes to 1/2 of the absolute value of 2x minus 1 over 2x minus 1 does not exist, because the limit as x goes to 1/2 from the right of blah, 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 is not equal to, and okay, I shouldn't be lazy, I should hold myself to the same standard you're held to, the absolute value 2x minus 1 over 2x minus 1, okay, that limit is not equal to the limit as x goes to 1/2 from the left of 2x minus 1 over 2x minus 1. Okay, so this is what a final answer would look like. All above it is the supporting work. Well, whatever. So now you might start to get skeptical, and you might say, gosh, every time there is an absolute value, the limit doesn't exist. So you know what? Why learn all this? It's clear that when the absolute value happens, the limit doesn't exist. Well, that's not true. So, in fact, we can look at almost the exact same problem. So let me make it a little bit trickier. Let's look at the limit as x goes to 1/2, 2x minus 1, but this time I'm going to square the top and put that inside of absolute values. And then I have 2x minus 1 on bottom. Oh gosh, oh gosh. And again, if you plug in 1/2, you'll get 0 over 0. So the first step that we should do is figure out our piecewise function. So absolute value is equal to the same thing that's inside when that thing is positive, and it's equal to the thing inside with the sign flipped when that thing is negative. And it turns out this is actually a really nice case, and I can do another one if you're curious, but in this setting, we will always, always, always satisfy the first condition. And you might be curious, why are we always satisfying the first condition? Why, oh why, is 2x minus 1 squared always bigger than or equal to 0? And the answer is because 2x minus 1, that's just some number, right? And any number squared is bigger or equal to 0. So yes, 2x minus 1 looks more complicated, but really it's just of the form something squared. And something squared is bigger or equal to 0. So this limit is just the limit as x goes to 1/2 of 2x minus 1 squared over 2x minus 1. And so this time, I just jump with an equal sign. There's no plus or minus up here because there's no need for left and right hand limits because it's actually not a piecewise function. We started out thinking, well, gosh, maybe it is, and we write it out. But it turns out this thing down here never happens. So it really is just this. So, okay, limit x goes 1/2, and we would get 0, 0, which means we have to do algebra. And it turns out we're going to cancel the 2x minus 1s, one copy on top, one copy on bottom. We're left with one copy of 2x minus 1, and that limit ends up being 0 as x goes to 1/2. Okay, let me do one more, hopefully a little bit more interesting. So this time, let's look at the limit as x goes to 0. And just to sort of show what's happening, we'll do x squared over absolute value of x. Okay, and this time absolute value of x is actually a piecewise function. This is x minus x, and okay, you get it. Hopefully you get it. So we have to check. All right, I'll write it out. Anthony. Don't be lazy. Don't be lazy. These two things can happen. We could have an x positive. We could have an x negative. It's not like the last example where you will never, ever, ever, for any x, you will never have 2x minus 1 squared is negative. That'll never happen. Okay, so these things might happen. So we have to check the limit as x goes to 0 from the right and the limit as x goes to 0 from the left. And when we're in case 1, x is bigger than 0. So we replace absolute value x with what it is when x is bigger than 0. So I have x squared over x, and this is the limit as x goes to 0 from the right, and I cancel a copy of x, and I'm left with x, and this is 0, because x is going to 0, so x is going to 0. All right, case 2, x squared. The bottom, which was absolute value x, is now negative x. So I have negative x. and that's the limit as x goes to 0 from the left. And I cancel an x, and I cancel an x, and I have negative x, and x is going to 0, so negative x, that still goes to 0. Hey, these are equal. So we can conclude the limit as x goes to 0 of x squared over absolute value of x is 0. So just because there's an absolute value does not mean the limit does not exist. And that even happens if you have a valid piecewise function. And sometimes it'll happen because it is a piecewise, but actually not. It just, they were trying to fake you, and really it was never piecewise all along. Okay, thank you.